Hello guys, let's begin our lesson. In this video, we're gonna learn about application of standing wave. The formation of standing wave produced by stretch, string, and air column. For the stretch string, in general, standing waves are set up in the strings of musical instruments such as guitar and violin when plucked, bowed, or struck it. For the air column, they are set up in the air column in an organ pipe, a trumpet, or clarinet when air is blown over the top. Basically, for the air column, we have two types. The first one is the open and whereby both ends are open. For the cross end type, we have one end open and another end is closed. So, the first one, formation of standing wave in stretch string. When a string of length L stretched between two fixed ends is plucked and then released, the transverse wave produced travels down towards the fixed end and reflected back. The wave pulse is being inverted when reflected. The wave and its reflection wave interfere according to the superposition principle and produce standing wave. The speed of the wave on a stretched string is given by V equal to T over U, where V is speed of wave on a string, T is the tension in the string, and U is the mass per unit length of the string with the formula U equal to m over L. For a stretched string, we can set up a standing wave patterns at many frequency. The more loops, the higher the frequency is. So now we have the table showing the mode, standing wave pattern and frequency of a stretched string. So the first one, fundamental mode. We have the first harmonic with the harmonic number n equal to 1. So this is the drawing pattern. So we have the simplest standing wave has one note at each end and no more. So the formula of the frequency is F1 equal to V over lambda 1 and we can substitute lambda with 2L. For the first overtone, which is the second harmonic, n equal to 2, our next possible standing wave we can make has an additional node in the center. So from the formula of frequency, F2 equal to V over lambda 2, we can replace lambda 2 equal to L to get the formula F2 equal to V over L. And lastly, we will get the F2 equal to 2 times of F1. For the second overtone, which is third harmonic n equal to 3. So the third possible standing wave has two notes in addition to the notes at the end. So that the formula of the frequency we will get F3 equal to 3 times F1. The standing wave on the string force the surrounding air vibrates and produces a sound wave in the air. But if the string vibrating in the fundamental mode, hence the sound wave produced is in the fundamental tone. This is a general equation to describe Nv over 2L, or we can have Fn equal to n times F1. So that's all from me. Thank you.
Assalamualaikum and hi guys. Today we're gonna discuss about 10.4.2 application of standing waves in air column or pipe. So basically, standing waves can be set up in a tube of air or air column, such as an organ pipe, as the result of interference between sound waves traveling in opposite direction. So standing wave ni akan berlaku apabila ada pertembungan antara dua wave, iaitu incident wave dan reflected wave. Dan standing wave ni akan berlaku dengan syarat both of the waves must have same magnitude, amplitude, frequency, and also speed. The relationship between the incident wave and the reflected wave depends on whether the reflecting end of the tube is open or closed. So dalam satu topik ni kita akan membincangkan tentang dua jenis A column iaitu closed pipe and also open pipe. A column open at both ends. So the general equation is Fn equal to Nv divided by 2L, or we can use Fn equal to Nf1. So a column open at both ends, all harmonics are present, which is 1, 2, 3, 4, and beyond it. So we look at the mode here. The first harmonic is fundamental. The simplest standard wave has antinote at both ends and one node at the center. And the length of the fundamental mode is 1 over 2 lambda. So we can find the frequency here using the formula V equal to F lambda and also the general equation. Now we look at the first overtone, which is second harmonics. The next possible standard wave we can make has an additional antinode in the center, and the length is equal to lambda. Then the frequency, we can find the frequency using the formula. We simply substitute to it and we get the answer. And now the second overtone, the third harmonics, the third possible standard wave has two antinodes in addition to the antinodes at the end, and the length over here is 3 over 2 lambda, and we can find the frequency using the formula and simply substitute into it and we get the answer. So now we look at a column closed at one end. So the general equation is Fn equal to Nv divided by 4L, or we can use Fn equal to Nf1. So yang membezakan antara closed pipe dan open pipe is kalau tadi open pipe dia all harmonics are present, but for closed only odd harmonics are present. So we can we see the mode here, fundamental always the first harmonics. So we can find the frequency using the formula, and also the length is 1 over 4 lambda. Oh yeah, I forgot to say why is 1 over 4 lambda. So this is one complete cycle of wave. So why 1 over 4 lambda? So we can see here, this is 1 over 4, di mana ia adalah suku. Jadi kita pakai 1/4 lambda. So kalau lihat di sini 3/4 lambda, sini 5/4 lambda. So we see the first overtone, the third harmonic. So kita boleh lihat first harmonics jump into third harmonics, and the second overtone jump into 5 harmonics. So we can find the frequency using the formula and simply substitute into it, and we can get the answer. Okay, that's all from me.
So for the question 10, the tension in a stretched string of length 50 cm, mass 1 gram is 100 meter. When the string vibrates, determine A. The speed of the transverse wave traveling along the string. So, from the question given, we know that T is 100 Newton, length 50 cm but convert into the SI unit, M mass 1 gram convert into the kg. So before we find the V, we have to find the mu. Mu is, by using this formula, we can find the mu. So substitute the M and the L in this formula and we can get the mu. 2 times 10 minus 3 kg m minus 1. So we can proceed to find the V by using this formula and substitute the T and mu. Then we can get the V 224 ms minus 1. For the question B, find the fundamental frequency. So, fundamental frequency, which means that n equal to 1. So, we can use this formula to find the fundamental frequency. And so, for n is 1, and we substitute the V that we already find 224, and the length is 0.5 and we get the fundamental frequency 224 Hz. So for the question C, find the wavelength of the note which is the second overtone. Second overtone which means n equal to 3. So we can find the firstly we have to find the frequency for 3 by using this formula. F3 equal to 3F1. So we substitute the F1 that we already find, and we get the 672 Hz. And we can proceed to find the lambda. Lambda 3 equal to V sound in the air divided by F3. So we can find the lambda 3 is 0.49 meter. For your information, the answer for A is wrong. So you can look at this answer instead of the answer given. Thank you.
A glass tube is closed at one end. The air column it contains has a length that can be varied between 0.5 meter and 1.5 meter. If turning fork of frequency 306 Hz is sound at the top of the tube, at which length of the air column would resonance occur? So first we need to take out these two formula, which is V equals to F lambda and F equals to V over 4L. And by comparing these two formula, we know that lambda equals to 4L. So we substitute V equals to F4L, which is derived from this formula, and substitute our F into 306, and we can get this formula V equals to 1224L. And by rearrange this formula, we can get that L equals to V over 1224. Then we substitute the velocity and we can get this answer, 0.27 meter. But 0.27 meter is not between 0.5 meter and 1.5 meter. So we'll proceed to the next formula, which is F equals to 3V over 4L. And we know V equals to F lambda, so we substitute inside this formula. And by rearrange this formula, we can get 3 lambda over 4, and lambda equals to V over F. And by substitute it, we can get 3V over 4F. Substitute the velocity and frequency in this formula, and we can get 0.81 meter, which is between 0.5 meter and 1.5 meter. So the next formula, which is F equals to 5V over 4L. So we will do the same thing, substitute V equals to F lambda, and by rearrange we will get L equals to 5 lambda over 4. Substitute again the lambda into V over F, and we will get this formula. Substitute the V and the F, and finally we will get 1.35 meter, which is also in between this range. So the final answer will be 0.81 meter and 1.35 meter.